Very comfortable in insulated environment. My fan is off.
That's a good thing. That's a good thing to have. Is this the new building? You're sitting in the new building?
No, no, I'm in an old building.
This is the old one. Okay,
Yeah.
but still insulated.
It's not. I was just joking.
I think we have gone live. So
Yeah.
uh, let me just see. I think we are good to go. So good evening, everyone. Hi, my name is Abdul Qadir Bengali. I am representing Pidilite Industries Limited from Dr. Fixit. Uh, Today, on the day of World Environment Day, our aim is to raise awareness of importance of respecting and doing our bit towards the environment. So today we'll be talking about a concept which is net zero home, which is a kind of a passion which we at Pidilite are pioneering. And we have with us a very eminent person in from the industry, Mr. Rajan Rawal, who has been kind enough to join us in our approach towards making India green, towards India sustainable. So when we talk about net zero homes, our endeavor and our passion is, can we make homes in India of individual homes as an off-grid air-conditioned homes? Can we have homes which are built which will be less on energy and which will be comfortable enough for us to have? With a bit to do in terms of saving the energy and saving the environment, it is also important for us to understand what the present situation is all about. And there are figures which are known to a lot of people who would have joined. And thank you very much for everyone to join in on this occasion. We are in a bleak situation where we see 200,000 generators which are being sold every year. This number keeps on increasing. We have seen a lot of shortfall in terms of use of energy. We have seen that a lot of energy is consumed by buildings, and it is important today for us to see and for us to make sure that power saved is equal to power generated. Otherwise, we are all in a dark future. Uh, Today, it is known that building consumes a lot of energy, and energy efficient buildings can help to reduce energy up to 50%. Uh, we at Pidilite believe, and we have taken the journey towards sustainability. We are known for waterproofing. Our endeavor and passion is, can we build in homes, individual homes, which can be not just a leak free, but also a heat free, leading to a happy occupant. Our passion is, and we have started the journey in terms of making healthy structures, and that is what we will talk about. Uh, we have been able to do this through a lot of technologies which we have brought in from across the world, but with a very clear insight of what works well for India. Hence, it is important for us to Indianize the systems which can work well for Indian construction, which can work well for contractors who are there in India constructing buildings. Uh, let me stop at this time, and let me introduce Mr. Rajan Rawal, who would be taking up a major topic of today's discussion, which is to talk about net zero uh, buildings. Professor Rajan Rawal is an executive director of Center for Advanced Studies in Building Science and Engineering at CEPT University in Ahmedabad. We are very pleased to have him with us today, who has joined us in our journey to talk about net zero building. Professor Rawal leads the Indo-US Joint Clean Energy R&D building. This center is recognized as a center for excellence by the Government of India, Government of Gujarat, and United States agencies. Professor Rawal is a member of various technical core committee. Uh, I can go on. I mean, I can spend another 30 minutes just talking about what Professor Rawal is doing great. but I believe he is walking the talk. He is currently engaged in constructing one of the early net zero buildings in India at CEP University, which is not just going to be a demonstration building, but it's going to be a live lab for energy performance and evaluation. So over to Professor Rajan Raval, and for us all to hear about net zero and what can it do.
Yeah, thank you, Abdul. Thank you, Pidilite, for inviting me on this occasion. And all of you wish you very happy Environment Day. What I'll be doing in next 20 minutes, 25 minutes available to me, I'll take you through a process of how do you really downsize your building for its energy demand, and how do you really target to make your building or even home a net zero home. So I'll be showing a kind of work which we have done in Ahmedabad, uh, and then probably at the end of this presentation I will be able to uh, take some questions if at all we have time. I'm sharing my screen now. I hope that you can see my screen. Is it visible, Abdul and team?
Yes, yes, it is visible.
Okay, so I'll be talking about the living laboratory which we have constructed. I think there would be a bit of response time. Uh, yeah, so I might take a while to switch on between two slides. So as Abdul mentioned that it's a center which is one of the kind in this part of the world, which tries to work on building energy efficiency. And our aim is to work at design level. How do you really make the building design or design process so that you can start doing energy efficiency at early design stage? We work on technology, kind of materials which we need to have, or kind of HVAC or lighting systems which we need to have to make our buildings net zero. And we also work on a policy level where we help government to take informed decisions regarding either codes or voluntary rating systems. As I mentioned that we work on pre-scales, policy, technology, and design. And the way we work is we actually work on various materials and various systems, and we characterize them for their performance. There are a lot of simulation tools available, and I'm sure that group who is attending this webinar is aware about various energy simulation tool or energy modeling tool where you can predict the energy usage of building much before you start construction. What we do is we try to feed into these models a kind of building characteristics it needs to have, or properties of building materials or building systems which needs to have. And we have a facility to characterize this. I'm elaborating this a little bit more because the building which we have made or we have constructed has been gone through the same process. So materials which we have used are being characterized or tested against certain standards before we have started using that. Now this particular process is now have ended and the data is in public domain. As an academic institute, what we feel that whatever we have gathered should be available in the public domain, and now we have a very large material construction database which has a listing of thermal properties or optical properties of the building materials. Now these materials could be vernacular materials or traditional materials, or they could be industrialized materials like insulations or glass. The way we have we started with a strip of land piece which is available to us, which was available to us in the rear part of the campus. And what you see right now on the screen is a university site map and a stretch which was available to us to construct a living laboratory, we call it. Uh, we had a few trees and we had to retain few trees. So the pavement which you see and a little bit of shrubs on the ground is what we have removed, and also so rather two trees which were a little small, which were removed. The trees which you are seeing on your right hand side of the picture, they have been retained, and that's the north side. If you see the map, you'll realize that that's a north side, and the building is oriented on east-west longer axis. When we started, again, what we believe is the building which is coming, which has come up on the campus, must provide an experience to occupant and also to visitors, which allows them to appreciate a kind of design interventions which we have done. So we had to look at what was the kind of traditional buildings Ahmedabad has seen in past 500 years. At the same time, kind of aesthetics and kind of buildings which we have on the campus, and trying to balance between these, we started our design process. The building right now is up, and we have started commissioning the building monitoring systems. Whenever you have a chance to come to Ahmedabad, you'll be able to see what we're doing. But point I'm trying to make is that building does provide various kind of experiences in terms of thermal and a luminous environment. For example, we have a basement, and I'll talk about that, which provides a little darker space, little subterranean space, and relies primarily on a passive cooling system, versus some of this test facility, which requires to maintain a certain thermal environment, does use a very efficient air conditioner, and that's where one can see, one can experience the condition or a very tight building environment as well. So building itself does provide various kind of experiences on thermal and visual environments. Before we start, I mean, the time when we started, we said that we would like to have an international experience, not only calling those consultants, working with them, but we also had local consultants with whom which we worked, and they actually helped us to construct the entire building over a period of 3 years. So what happened is an international consultant came in the early part of the design. We did some conceptual planning with them, and with the local consultants when we did detailed design and execution. So I think most of you would be aware about what is a net zero. Basically, you're trying to balance between your operational usage. I mean, I'm getting a lot of background noise. I'm not sure whether you guys are getting a background noise or not. Abdul, are you getting a background noise?
No, Rajan, there's nothing over here. Maybe.
Okay. Okay, so I think I'm only getting the background noise. Anyways, so the building which uses whatever amount of energy, if it can generate same amount of energy over a period of 1 year, one can probably put that kind of building in a net zero building category, where your consumption and your generation on-site, or rather on-site generation through renewable energy sources needs to come together and needs to match. I know that to make a building net zero, you can't state that my building is I have designed a net zero building. The correct way to state it, I have operated my building in a net zero manner. So probably after 1 year or so, I will be able to tell you whether my building is actually a net zero building or not. And over a period of time, we will keep on measuring these things. How much are we generating, and where and what we are using. So the exercise actually started with looking at kind of environment which we need to face, the exterior environment and kind of interior environment which we need to have. And if you see the psychrometric chart with the outdoor temperatures in Ahmedabad, you can see that we have very less hours available to us where you can be in a comfortable zone. Again, I'm using a word adaptive thermal comfort, where what we're saying is that you don't maintain your buildings at 22 degree ±1 across the year, but as human beings, we do interact with the outside. So if you have outdoor which is 44 or 45, you definitely will be comfortable more at 27 or 29, and you need not to be at 22 degrees centigrade. Uh, and that means a lot of savings in energy. The building design, which we have done is keeping the adaptive thermal comfort model, which we have developed in India for India, based on adaptive thermal comfort standard of ASHRAE 55. The building is going to provide a comfortable situation as per Indian standards and not as per any other European or US standards. So I'll go talk about net design process now. We started with charrettes, where the 3 charrettes took place in person and around 20 virtual meetings with the consultants. This is extremely important step where everybody from the contractor to a user and even a facility manager who is going to operate a building needs to be on board from day one. So along with the architects, structural consultants, and energy consultants or energy designers, you need to have people who are actually going to construct and operate the building. So we started with that, the various kind of the priorities on our hand, and then we say that, okay, if the building needs to be net zero, do we really need to have any kind of reference? So how much do we use right now, and how much downsizing can we do? This is extremely important to understand. You can have a net zero building in a present state also without doing anything to your building. For example, where I'm sitting right now, we might be using around 250 kilowatt per meter square, and I can make this net zero by putting a very large amount of solar PV panels somewhere or right on top rooftops. But that's not the case. You definitely need to downsize. First, you need to downsize the demand. That is, you need to design your envelope in such a manner that it does use less energy, and then you put a very efficient system. When I say system, it's a HVAC and lighting systems, so that you can use less energy or you consume less energy. Now, whatever less energy you consume, it needs to get supplied by renewable sources. And that's how the 3 stages, you need to size and you need to design your building so that it can become net zero. So we started looking at what happens on the CEPT campus. And as you can see, some of the buildings on CEPT campus uses somewhere around 237 kilowatt per meter square per year. And we say that if we start downsizing ourselves, looking at heating, cooling, fan and pump energy, domestic hot water systems, lightings, and equipment, how much can we downsize? And we said probably we'll be able to achieve around 76% of energy efficiency. With such an amount of heavy equipment load, we said we might be able to reach to 58 kilowatt hour per meter square per year. And that's how we started our next step of designing the buildings. And so this is sort of target we set before we started doing any kind of sketch design. So these are the sort of pre-design directions which took what is sort of consumption limit, what's the kind of shading potentials we can have, what would be the connected lighting power density we should target, and that's very high, as you can see. Plug load reduction, how do you really reduce the loads? Can you rely on a direct evaporative cooling for certain time, and what can you have a sort of CO2 controls for outdoor air when it gets into the seminar rooms and office? So various kind of pre-designed conditions. We said that let's start moving ahead. Next. And what we said is let's try to use energy the way it gets in. So if heat is getting in, do not try to change that form and straight away use that heat for some purpose. If light is coming, straight away start using that light. Do not try to turn into the electric light and start using that. So with a bit of design, decision making, analysis, and brainstorming, I will show you some of the examples and how we have arrived at decisions. So with the various kind of design options, and on the right hand side, so that each design options we got some kind of numbers. We started doing adaptive model, how many times can you be in comfortable without using any kind of air conditioner or any kind of fans, and that can we really increase the situation. It is an extensive shading analysis because that's what India needs. You might require a high U value or high very good solar heat gain coefficient the glass or windows. The moment you start shading your building, you are much better off. You can shade your building with the surrounding buildings, or you can shade your building with the trees. So shading analysis becomes very, very important at the early design stage. As you can see here, that some of the daylighting analysis which we have done, the kind of exposure you need to have with the sky, we have started doing that, started providing certain kind of clear story. These are the sort of daylight analysis areas which we have focused. Fully glazed on the northern side, having a bit of sizing of lighting shells, whether you should have 500, 600, what would be the height, what would be the interior wall finishes, what would be the south facade and vision windows, because it's not that you just need to avoid the windows. People would like to see outside. And if you start providing vision windows at a certain level with a lot of good shading, it definitely is going to help. When you start getting into the basement, how do you really bring in a light much deeper inside the floor space? Do you need to do any kind of geometrical characterization or any kind of modulation in your floors? And that's how we started looking at the daylight. And then extensive analysis on not only the visuals, but also numerical analysis we did. These are some of the screenshots from Radiance model, taking the width of the windows and how much can we have, how much can we not have. Again, kind of cooling technology potential. And Ahmedabad does not offer much except for the thermal mass. Whatever happens outside, and even the moment you start operating your building in natural ventilation, what is happening outside will come inside after 3 hours or 4 hours. So looking at the temperature, looking at the ground temperatures, also if at all you need to have a water tanks underground, can you really take the advantage of the cool water which gets stored and look into some of the cooling systems. Because we are going to rely more on the natural ventilation and thermal comfort, it's extremely important to look at the computational fluid dynamics, the analysis, not only for temperature and RH, but also looking at the indoor air quality. Because if you're urban, if you're in middle of the urban area, and if you don't get a good outdoor air quality, doesn't make sense to make a building which is naturally ventilated. So we did that analysis. We did a lot of cost optimization, looking at labor cost, looking at the material cost, and looking at the operational cost. And we say that probably various kind of permutation combination we may be able to target. We call it bundle approach, and probably bundle 3 is probably cost effective at the same time giving us a maximum amount of energy savings. Once we had that, we said that, okay, let's start looking at the solar PV potentials, because right now site doesn't offer anything other than the solar PV. We did look at this biomass, we did look at the solar thermal, but the size of building is such that probably solar PV is the only option which one can block. And therefore we started looking at what could be the capital investment if one has to put a solar PV, and then what would be the sort of generation. On academic side, we relied completely on building information models, because that's what our research area is also, where we are trying to combine a building information model with the monitoring systems. These are some of the shots where you can actually see the conflict with resolve between various services, and you start looking at the building in a virtual format as it gets built. So what we design? We design basically a good daylighting systems. Design vision clear story light shells. We designed the stack effect to allow the solar chimney for natural ventilation. We did design a ground heat exchange by putting some of the seminars area in the basement. We optimized envelope heavily. We relied on a low LPD, which is like around 4.7 watt per meter square, again in the some of the areas which requires exhibition and stuff like that, and we started relying on radiant cooling. And so that's the kind of building which has come up. The building itself is a living laboratory for us. We'll be experimenting with the building itself. We have put in around 900 sensors across the buildings to monitor various end use or various environmental parameters of the building. That's how it looks from other sides. The features is, as I say, that with the daylight autonomy, we are getting around 90% of the spaces completely daylit. Window to wall ratio is around 90 to 20%, and still we are getting a full daylight. And then a lot of optimization on building systems and HVAC systems. Release. This is how our savings by measure. Around 44% savings are coming basically from integrated passive and active cooling systems, and another 16% is coming from daylighting controls. Vacancy sensors, insulated walls and roofs, plug loads. So these are the sort of envisaged savings by the measure. What we learned, we said that iterative analysis and design commitment for the performance-driven solution got us there with a low added cost. Being an academic environment, we were extremely conscious about having the cost factor in the design and construction all the time. Use energy the form it is in. If you're getting daylight, start using that. If you're getting heat, or if you're getting nighttime ventilation, outdoor air, which is at the lower temperature, start using that in its own form. Net zero architecture has focus of daylighting, passive cooling, and responding to the active systems also, not only relying on passive systems, but when you want to perform, when you want to increase the productivity of the people, you definitely would love to rely on active systems, primarily in the areas where Ahmedabad is. There's no silver bullet. Every kilowatt hour counts. It's not that golden rule that you have to design a building in XYZ format. Each building is unique and requires enough amount of rigor before you start looking at any kind of numbers. Building users and owners who understand the use and operation are extremely critical. They must be part of the process much early in the design phase. So a bit of jumbled slide, but requires to achieving a different results. And the new formula is that a building needs to perform. You simply cannot rely on intent-based approach. Yes, you start with a better intent, but finally you need to have numbers to prove that intent objectives are met with certain kind of technologies and certain kind of interventions. So that's very brief and very quick the introduction about what we are doing. Primarily, if I have to summarize, I will summarize in a manner that you must start with the integrated design process. Bring on board all of those who are going to use buildings and going to operate your building. Downsize your energy demand first with the building. Go into the insulation, use better glass, use the design features to downsize your building energy demand, and then use efficient systems so that you do not load the renewable energy systems much. It's not that by putting a renewable energy systems you can make your net zero building. It all depends upon how are you downsizing. So if at all I have to summarize this in one line, I would say downsize your first and then rely on renewables. Thank you. Abdul?
Thank you, Rajan, for that wonderful insight. It's really walking the talk is what you have done, and I think and I believe that a lot of people would have learned from a lot of good things which you are doing.
So there are some questions coming up. We'll address them later on, right?
Yes, we'll address them later on. I will move on to the. Can you see my PPT? Is that visible?
Does your PPT have your face? Yes, we can see now.
Okay, great. I hope a lot of people who have joined could have also seen now. Once again, thank you, Rajan, for really taking us across through a lot of great insight. From whatever great Rajan mentioned, we at Dr. Fixit would want to share you one of the concept which he mentioned about downsizing the demand. what we did was really to understand that does it make sense for us to insulate a structure and does it help. We have put in 3 test house which you can see on the screen at our facility in Cochin, where all 3 looks exactly identical. But when you look at the building 1 where my arrow is versus the building 2 and 3, the building 1 consumes 50% more power. So these are 3 energy meters which we have plugged in. There is an AC which is running it inside. We do set temperatures which are not as correctly identified by Rajan, 22 degrees centigrade or 24. We set it around 26. We do simulation at 28. What we have seen is that the energy unit which is consumed by this home is 50% more as compared to the rest. And we have been able to see this for the past 2 years. This setup was done 2 years back. We are trying to see various ways and means by which we can optimize, do permutation combination, and come back on what is workable. What we found out is while it is very important to talk about comfort, it is equally important to talk about thermal stresses. It is equally important to talk about sustainability of the structure in itself. And what we found that as a normal building, a conventional way of construction, when we measure the bottom slab temperature, the red line is what we found. The day when we measured it, the ambient was 36 degrees centigrade. And what we found is the bottom temperature of the slab moves from around 45, which is the peak, and it drops till around 34, which means there's an 11 degree delta T which a slab is observing in a normal day of 36 degrees centigrade. I'm sure when the temperature is higher in places like Ahmedabad or Delhi, the particular graph would move up. The delta T will go up. What it indicates is the roof is subjected to a lot of thermal stresses, and it is important for us to minimize and create a lag, thereby we can help to improve thermal comfort. 20 feet away, the next building which was there, we found that the graph is pretty straight, which kind of demonstrated that an insulated structure would not just make a building comfortable for people, for occupants inside, but they will also help to improve the life of the structure. It's very important for us to be comfortable, and again, like what Rajan said, it's important to look at our way of comfort and not what is applicable in US or other part of the world. What we found, and this may be evident, a lot of people who are on the call, once you go back to your home, or if you are at your home right now, you can see when the evening sets in, which is the blue line, which is the ambient temperature, as the evening drops in, the inside temperature of the room or an office, if not air conditioned, is much warmer as compared to the ambient, which is because of the thermal mass effect of the concrete. It does not give us a comfort we call as evening discomfort. Whereas what we found is by using an insulated structure, the entire temperature is much comfortable. This is the green line is denoting it. Temperature is still higher, while the temperature of a conventional building is much higher. An insulated structure is much cooler. Now there are different strategies of insulating it. What we are going to be talking, what I'm going to be talking about, is one of the strategies. You can insulate a structure with different ways, different material, different system. They are good enough in their way of working, and they can work. The critical part is, as what again Rajan said, can we downsize the building requirement and the demand, whereby we can make it off-grid. So as Dr. Fixit, our passion is, what we are working right now is, while a large building will have different challenges, can an individual home, which is still a major part of Indian construction, can we come with a system which is off-grid air-conditioned home? Can we reduce the entire demand of a building whereby by solar AC or by affordable system which is hybrid in nature, we can maintain a comfort inside a home. And that's our passion which we would want to uh, throw it across to everyone on the day of World Environment Day. So what the system which we have launched, which is working very well, we have been able to demonstrate a lot of savings. It's a green system. It's a spray applied system which goes on the roof. It's sustainable. It gives permanent weatherproof to the extent that we as Dr. Fixit talk about giving waterproofing guarantees of 25 years, 2.5 times of what the conventional or the present market talks about, precisely because we believe that the system is going to last long enough for it to work. As a system, this would reduce a lot of heat to the extent of 80 to 90%, save energy, also helps in terms of faster completion, and as I said before, the system is executed and guarantee is offered by Pidilite. This system has very well been used. I'll be happy to share a case study of a project which again happens to be in Ahmedabad. It's a prestigious hotel which has come up in Ahmedabad, which was a green building. They were looking at a lot of conventional systems earlier. They had a challenge that the roof was used where they had multiple pedestals, multiple systems, MEP systems coming on top of it. So they wanted something which would work well, at the same time save a lot of energy. And after a lot of permutations, a lot of analysis, there was a rigor in terms of selecting it. They chose Dr. Fixit LEC system, which was proved through certain figures that it helped to save 82% of the heat. It helped to save close to 30 tons of AC. The payback for this, as compared to a conventional system, was immediate. So, what they could save over a period of life cycle was not just something in the initial investment, but they could save somewhere around 2.25 crores of pure benefit with a 25 years of guarantee coming in from Dr. Fixit, from Pidilite, as compared to a conventional system. So what Professor Rajan said about downsizing, there are technologies which are being used, there are systems which are being used. What we all are recommending on the day of World Environment Day is it's our bit to be able to do and give back to the environment. I'm sure a lot of you are aware of the stats, figures that between now and maybe 30 years or 20 years, if we all were to be alive, we will see 3 more Indias coming in. And if we have to have so much of construction, it's important for us to design it correctly. It's important for us to downsize the demand so that the needs can be maintained. Hence, I would like to just conclude by saying it's important for us that we be the change, and we be the change you would want to see in the world. And each one of us can make a difference, because none of us would want to live in an environment which does not have water, which does not have electricity, which does not have a good way of living, because we all want our children to be happy. We all want to live in a green, sustainable environment. Hence, on the important day of World World Environment Day, from Dr. Fixit, from me, and on behalf of Professor Rajan Rawal, we want to thank each and everyone who has joined us, because you would want to make a difference. And hence, thank you very much. We wish you once again a happy World Environment Day, and we'll be happy to take questions now if you have.
Can you hear me, Abdul?
So Raj.
Yes, there was one question from Neha Ghosh. The question was that what are the challenges have you faced during the execution? of the large project. Now, there are a number of challenges we face, but one of the most important challenge which we face is about the notion of return of investment. Uh, and we do preach about this, that you downsize yourself, you downsize yourself. What does it mean? When you're downsizing yourself, that means that instead of 100, you'll be using 50. Now, when you're using 50, and then your demand is 50, then you put some more efficient systems, you further reduce your consumption from 50 to 25. Now, at 25, if you save one, you will be, or rather, when you don't use more energy, you are likely to save less, and therefore the return of investment kind of word becomes misnomer. Return of investment comes when you use something. When you don't use something, you cannot save anything, and that means you don't get any kind of return. So sometimes to my students, we do discuss that if my return of investment is 80 years, we are very happy, because that's where you are saying that I am not using anything. So I would say that economics is the main challenge which you face most of the time when you start managing either a smaller project or larger project. We do have a technology, we do have a design competency, but somehow if you can work with economics, you will sail through.
Rajan, there is one more question which is there, which talks about where do we see ourselves 10 years down the line on net zero buildings in India? The question comes from Shwetank Srivastava.
It's difficult, but I would say that if at all we can build 20 buildings in next 10 years, just 20 in next 10 years, which we can call it a really true net zero buildings, I think we'll be doing a great job.
Rajan, I would want to invite a question. What if we were to make an off-grid air-conditioned building? Net zero building, large buildings are great. And what if, is there a possibility of saying, can the homes be made as off-grid air-conditioned?
Yes, I mean, if you talk about the typical bungalow kind of the building typology, or a row houses kind of building typology, it's easier and probably feasible to make them air conditioned, at the same time relying on solar PV or any other renewable system. But if you look at the urban space, I would say simply go for efficiency and not for rooftop generation or any of those ones. So individual bungalows, it's easy, it's possible.
Thank you. I think we'll wait for a minute or two more for some questions if they are coming in. Rajan, a question on behalf of the audience from me. Is cost the prohibitive? Is the cost the barrier for scale up of net zero buildings in India?
No.
Is awareness?
No.
Then why is it that when you said that if 10 buildings comes in 10 years, we'll be happy? Why can't 100 buildings come in 10 years?
See, it's all about the faith. It's not about money. People don't mind spending money if they're getting what they want. But when after spending money, they don't get what they want, then things become very, very crucial. And that's where I'm saying that if I am saying that my building is going to perform better, somebody needs to vouch that. And that third-party agency also needs to have a credibility. Today, if you ask builder that will you make a green building, he will say yes, I don't mind making a green building, even with the additional cost, because that cost is going to get transferred to the consumer end of the day. But if I have to compete with somebody who doesn't make an energy efficient building, then for me it's very difficult proposition. How do I compete? So I would say it's for kind of technology available, kind of products available, it's all matter of faith. And we don't have faith because there are various kind of players in the market trying to sell that product. If I spend 50 rupees more or 50% more, I must get that amount of performance back. And we don't have faith what I'm getting.
So on other side, buildings like your can really be a demonstration for the industry to say that yes, it is possible, and that would definitely drive a lot of growth towards green or sustainable or net zero building.
That's correct. So if when I say 10 buildings, I would say one building, if you say that it is deploying 5 to 7 technologies, 10 buildings will deploy 60, 70 technologies. And we have a 60, 70 technology test bed available for people to jump and said, okay, now we are ready to make another 20,000 buildings which are net zero.
Right. So, yeah. Okay, let's wait if we are able to get some more questions around from people who have been kind enough to log on a Friday evening to hear us. But I think that is everyone who have joined in. Thank you very much. It's been kind for you to join in. A very big thank you to Professor Rajan Rawal, who has been kind enough to spare his valuable time to join us and give us a good insight on net zero buildings. I would definitely hope it's not 10 buildings in 10 years. It's much more than that. And with the great work which Professor Rajan is doing, I think this will happen. So once again, thank you everyone. It was great for you to have it over here. Thank you, Professor Rajan Rawal.
Thanks for inviting. Thank you.